Welcome to this lesson on scale factor. We're going to talk about how to determine the scale factor in similar objects and recognizing that when you're looking at enlarged or reduced distances in scale drawings that they're proportional, so the corresponding distances or sides are proportional, and how to use the scale in a map to find actual distances, and how to find the area of a larger object using scale. Right? And then we're also going to be talking about creating a picture of a similar figure using the scale factor. So some of this is going to be split over 2 days, and we're going to be covering a good chunk of it in this video and then working on a lot of stuff in class. So here we go. First and foremost, our vocabulary. So first we need to understand that a scale drawing is a drawing of an object that is proportional to the original. So we talked about similar figures and how they have to be proportional in order to be similar. Same thing with the scale drawing, except for now you're talking about a drawing of like a blueprint or a map, something like that, instead of just a regular shape. Right? So examples here, again, like I said, we could say a blueprint, or a map. Oh yeah, that's an M. There we go. And then scale factor, we briefly touched on this earlier, but the scale factor is the ratio that compares a length in a drawing or model to the original length of the actual object. Okay, so it's how, mathematically, it's how we compare the two objects. So if you're looking at, and we're just going to do the triangles again, if we have 3, 5, and 4, and then we draw one to scale, and we have 6, 10, and 8. The scale factor is 2. So it's how we go from that enlarged object to the reduced object or vice versa. Right? And we also want to remember that when the object is getting bigger or being enlarged, you're going to have a scale factor that is above 0. Or I'm sorry, not above 0, that's above 1. And when you have a scale, or when you have something that's being reduced or getting smaller, it's going to be less than 1. Alright, so we're going to start off with a couple easy examples here. So in the map, the scale is 1 inch to 100 miles. So this right here is really important, and we box our important numbers. We want to find the distance between Winston, so that's pretty important, and Clarkston. Right? So in order to find the distance between Winston and Clarkston, we're going to have to use a ruler because we're using a map. We're not actually physically driving it and using the odometer. We're going to figure it out using the map, and we're going to use that scale. So what that scale tells me is that for every 1 inch that I measure on my map, in real life, it's 100 miles. So that should be proportional to what it actually is in real life. And here, we're going to find what the inches are because we can measure the inches in order to find our missing miles. So what we're saying is if I can find the distance on the map, I should be able to use my proportion because they're similar. I should be able to use that proportion to find out how far it is in real life. So I'm going to take my ruler and I am going to measure from Winston to Clarkston. And now I have to measure, I have to be careful. So right now I'm measuring in centimeters, but like it said, it's inches. So I'm going to move my ruler up to make sure that I'm using inches. Actually, I can probably just flip it. That'll be easier. And I put the 0, I start with the 0, right in the middle of where I want it. Okay. All right, and now I'm going to take a look and I'm going to use my measurement of, we're going to go with 2 3/4. It's a little hard to see, but we're going to use 2 3/4 to make it a little bit easier on ourselves. So in this case, it's 2 3/4. Now, because we haven't really talked about multiplying and dividing with fractions just yet, we're going to turn this into a decimal. So I know that 1 inch to 100 miles has to be proportional to 2 3/4 inches that I measured, and that should give me my miles. So now if I multiply, I know that 2 75/100 times 100 has to be equal to 1 times m. Well, the nice part is 1 times m is m, so basically I can do this in one step. Okay, I multiply this by 100. When I multiply by 100, I know that I can just swing my decimal 2 places to the right because it's 2 zeros. So between Winston and Clarkston, there are about 275 miles. Now this isn't going to be perfect because of the fact that there's room for human error. So here, trying to read the ruler, there's human error if it's off a little bit. So if my ruler moved a little bit left or right, and there's also the fact that it's not always going to be perfect. So we always say that it's about 275 miles. All right, moving right along. Now I have a word problem that talks about the scale of a map, and so I have to be able to identify the important information. So again, when I'm doing that, I want to make sure that I'm using my cubes. I'm circling important numbers, I'm highlighting the question, I'm circling the operation words, boxing important numbers, and then evaluating and solving. So here we go. So the scale on a map is 4 inches to 1 mile. So that's going to be important. The distance between two cities is 20 miles. So again, that's going to be important. And I want to know how far apart are they on the map. So the first thing I want to do is I want to set up my scale. And I should always have my scale on one side and then my other information on the other. All right, let me make that eraser bigger. There we go. So now my scale, I know, is 4 inches to 1 mile. I could flip these as long as I make sure that I'm consistent. Okay, so if I had put miles on top, I would need to make sure to put miles on top on the other side as well. So now in this case, I want to know how far apart are they on the map. In this case, the map I know would be measured in inches, so I know that I'm looking for my answer in inches, and I was given miles, so I have my 20 miles in the proportion. Again, we know how to solve, so we take 4 times 20 is equal to 1 times I. I know 4 times 20 is 80 is equal to I. Okay, so on my map, the two cities are 80 inches apart. So far, this is pretty straightforward stuff that we've worked on before, so I'm kind of going through it a little bit more quickly. Now we're coming into a little bit more difficult of a problem. So we have Vincent who's trying to get a basketball court approved at his school, and he needs to follow some guidelines that the administration gave him. So let's take a look at this. All this information in the beginning is just setting up the story problem. So really, there's nothing important until we get to about here. All of this up here is background, right? So after checking with the school administration, he is told that it'll be approved if it will fit on the empty lot that measures, well, if it has to fit on the empty lot, we know that 25 feet and 75 feet have to be important. Okay, now, will the lot be big enough for the court he planned? So we are given a picture of the court that he planned, and here's our question. We highlight our question. So the court that he planned is 1 2/3 inches by 2 inches. So here's where we have to use a little bit of common sense. So we have 25 by 75. So because this side is smaller, I would assume that this is going to be my 25 and my 75. All right, so I want to know, is this basketball court going to fit within here? When I look at this, in my problem, it doesn't give me any information about the scale. It doesn't say how big, did he just roughly sketch this, or did he actually use a scale model? So I have to look at all information, and if I look right here, I find out that 1 inch on my drawing corresponds, which is important, to 15 feet of actual length. So my scale factor is 15 to 1. Okay. So now I'm trying to figure out, is my court going to fit inside of here? So basically what he drew is this going to fit within the 25 feet, and are the 2 inches going to fit within the 75 feet? All right, so what I have to do is I'm going to have to set up a proportion. Again, I know that the scale is 15 to 1, and he drew it 1 2/3 inches, and we're looking for the number of feet. Now, we're not looking for 25, we're looking to see, is this going to be, so x can be less than or equal to 25. It can't be any bigger or any smaller. Or I'm sorry, it can't be any bigger, but it can be smaller. So here, we know that 15 times 1 2/3 has to be equal to x. So I'm going to set that up. 15 times 1 2/3 has to be equal to 1 times x. Well, I know 1 times x is just x. And I know that in order to multiply with fractions, I have to change it to a mixed number. So I take 15 and I multiply it by, okay, so I have one group of 3, which is 3 plus 2 is 5, over 3. I put the 15 over 1. I can actually simplify here. 3 divided by 3 is 1. 15 divided by 3 is 5. So I know 5 times 5 is 25 over 1 is equal to x. So I know that this length right here, his scale drawing tells me that it will be 25 feet in length. So I know that, yes, this will fit. Right, so right now he's doing pretty good. He's got a length that will fit, and now we need to know if the width will fit. This would be a perfect opportunity, if you feel comfortable to do so, to try the problem by yourself to see if you can figure out if his scale will work for the 2 inches. If you're not ready to do that, you can absolutely continue to work with me. What I'm actually going to do, because I am running out of space, I am actually going to copy this page and paste it, so that way I can give myself a little bit more room here and you guys aren't trying to squint to figure out what I'm doing. Alright, so I'm just going to go ahead now and erase the things that I don't need, which is just all of this work down here. Alright, now I'm working with the 2 inches. I need to know that this fits with 75. So 15 feet to 1 inch has to be equal to, and actually I'm not going to use x because I already used x. Let's use y. And he drew that as 2 inches. So set it up. I have 15 times 2 has to be equal to 1y. 1 times y is y, and 15 times 2 is 30. Well, since I know that this is significantly less than 75, I know that it's going to fit. He is going to be able to have that basketball court put in because it will fit within that boundary. Again, it doesn't have to be equal to 30. It just has to be smaller than or equal to 75. So right now, we found out that his drawing equates to his court being 30 feet by 25 feet, which will fit into what the administration said. It will fit in the 25 feet by 75 foot area. Right? So that's the example of using a scale drawing to figure out the actual dimensions. It's much like what we were doing with the map. This is where things get a little bit trickier. So now we're talking about scale factor and area. This is where I really want you to slow down and pay attention to what's going on and pause and really look at it and process. So first we're going to start with this one right here. So we have the actual picture, which is 4 units by 3 units. Okay, so 4, just in case you can't see it, by 3. So the actual area we know is 4 times 3, which is 12. In this case, my scale factor, everything is going up by 2. So my scale factor is 2. If you look at and figure out the area, so this is 8 and this is 6, when I look at it and figure it out, I know that 8 times 6 gives me 8, and 6 gives me 48. Now, I know that with the scale factor, what we did was we said, okay, well, if this doubled, we would think that this should double. So if we double the length and double the width, we tend to think, oh, well, then the area should just double. But you have to remember, you didn't just add, so it was here, and then you added all of these. And then you had this, and now you added all of this. So you didn't just add one row, you added this whole section here. You added a whole 3 by 4 section to it. You took this square here, this rectangle here, and you doubled it. So you doubled the entire thing. You didn't just say, okay, here is this 3 by 4, oh, I'm just going to make this line longer. No, you actually included all of this in here. All right, so that's why it looks different, because you have to remember you're adding to that picture. You're not just making the one side longer and the other side longer. You're adding a lot more to that inside space. So now we're trying to figure out, instead of having to do this every time, figuring out the length and the width and then the area, let's make a connection here to here. To do that, we're going to take a look on this side at how this works out. So in my actual picture, it's 6 by 9. So my area is 54. In my scale area, it's 2 by 3, which is 6. Now, we talked about this. We said, okay, well, to go from 6 to 2, I divide by 3. But when we talk about scale factor, we don't say dividing by 3. We have to turn that into a multiplication problem. And we know dividing by 3 is the same thing as multiplying by 1/3. Right? So we end up, if you know that you're dividing, if you're going from an enlarged picture to a reduced picture, you know that your scale factor should be a fraction. So in this case, my scale factor is 1/3. So now I'm trying to figure out, how does this scale factor connect back to this area? Well, let's take a look at this. So here, if I take my scale factor, I know that it doubled, so my length and my width doubled. But my area, when it doubles, it actually ends up being squared. Okay, because with area, we're adding all of this, not just a small piece. So we'll go over more of the explanation in class, and right now I'm just going to focus on the math of it all. So if I take the scale factor and multiply my area, so if I take the actual area and multiply it by my scale factor squared, it should give me my scale area. So 2 to the second power is 4 times 12 is 48. So let's see if that works over here. So I have my scale factor is 1/3. And I'm saying that if I take that and square it, I should be able to multiply that by my actual area to get my scale area. Right? So to square 1/3, remember that means 1/3 times 1/3 times 54, and we put that over 1. I'm going to actually take that equal sign out for right now. Well, 1/3 times 1/3 would be 1/9. 1 times 1 is 1. 3 times 3 is 9. If I multiply that, okay, so I have 1 times 54 is 54. 1 times 9 is 9. And I know 54 divided by 9 is 6. Did it work? So I got 6 here, and I had 6 here. So what's happening is, like I said, you're squaring that scale factor because you're adding a two-dimensional shape. You're not just saying, okay, I'm taking this line and I'm doubling it. You're saying, I'm taking this box and I'm doubling it. Right? So it all has to do with dimensions. So what I want you to write down so you have it for access later is that to find the scale area, you take your scale factor and you square it, you multiply it by your actual area, and that should give you your scale area. Again, this is just the introduction piece to it. We're going to be going over this a lot more in class, but I really want you to be able to understand and work with this, and we'll work on the deeper part of it when we come in. So I want you to be able to use this equation to help you find your actual or your scale area. All right, now you have some U-try problems that I need you to do on your own. Again, you have a couple of problems where you're using the map, and then you have a problem where you have your tablet and it's going into, you're taking a picture of it and the picture is going into the advertisement. And so you have to find your important information and all that fun stuff and make sure that you set up your scale correctly. Slow down and put it together correctly. In your second U-try problem, so that second U-try problem is using the same information and you need to change it. It's not asking what will the length and width of the advertisement be. I apologize, I didn't change that. It should actually say what is the scale area. So you're using that last part again. So the question should actually be, what is the scale area of the advertisement, or of the tablet in the advertisement? All right, so make sure that you write that down so that way you answer the question, you're answering the correct question. As always, if you have any questions, make sure to type it in on your self-assessment or email me or write them down so we can go over it in class.